So last week we talked about fluids. We started off with how we can find density being mass over volume. Remember, that's not mass times velocity. This is a different letter. This is rho. And then we also talked about specific gravity. Specific gravity is the density of a substance versus the density of water. It's that ratio, and it has no units because they would cancel out. Pressure is force over area. And then we talked about this image where we have our cup. And how do straws work? Well, for the liquids to not be moving, we balance our forces left and right. We balance our forces top and bottom, up and down. But then for the straw to work, we get rid of the pushing in the straw, okay? And the atmosphere pushes down on the liquid, which pushes up the straw. This is like if we were to inflate a juice box to where it pushes back out of the straw. Today, we're starting on hydrostatic pressure. That's the first blank out of the gate. Hydrostatic pressure. So we have hydrostatic pressure or gauge pressure. What do you think of when you think of hydrostatic?
Water.
Water. Okay. All right. Go ahead and read this right here. I'm going to pause it. Alrighty. So we're going to start with two of the equations that we know. It's talking about pressure and it's also talking about density. Did you get that feel? So give me some equations that you want to work with. P equals F divided by A. That's a good equation. Anything that deals with density, what is density? So rho equals M divided by V.
Yeah.
So mass divided by volume. Why don't we start by rearranging this mass divided by volume? I think it would be most useful to get mass equals rho V. We're going to be working with forces and mass. Wait, forces and mass. What does that remind you of?
Force.
What's pulling down on the foil?
Gravity.
And what's pulling down on the water above the foil? So why don't we use mg as the force above it, pulling down?
Over A.
Over A.
Okay. And then M is just rho V.
And m is rho v g over A. Let's talk about each one of these letters. Rho is the density of water above the aluminum, right?
Mm.
V, what is V?
Volume.
The volume of
Water.
water above the aluminum, right? Any of the water that's stacked above it. G is just what planet we're on, gravity. And A is the area of the contact with the water, which is wait. The area of the aluminum is a length times width, right? What's the volume of that?
0.
Length times width times height. So this area can cancel out with the volumes length and width, leaving just the height. Yes. So our pressure will equal the density of the liquid, not times the volume. What did we say? Times the height and times gravity. So rho GH. Density times gravity times height. In fact, let's write that down below. We're going to write down below density. Density of the fluid, right? Times gravity times the height. The height of what? The height of
The world column.
the water above it, yes. And so that's what we will call it. The height of the column of water. Or fluid in this case, right? In every case. Fluid, right? And you might call it height. Mount Everest has height. But if we were going down to Marianas Trench, we would call it depth. So we could also say depth. Okay? Now, absolute pressure, this is just more vocabulary, also includes atmospheric pressure. So we need to add 1 atmosphere. The problem with that is 1 atmosphere, 1 ATM, and the unit of ATM is less convenient for us as physicists. A lot of times we're talking about newtons and meters, and so newtons per meters squared pressure is what unit? Okay, again, when we add this atmospheric pressure, right, we need to remember what unit. 1 atmosphere equals 101.3 kilopascals.
Yeah.
So another way people will write that is 1.013 times 10 to the 5th pascals. Or we could see that both of those means 101,300 pascals.
Yeah.
Okay. So those are some common ways that you can see it written out in the wild. Because of this, because it's kilopascals, you might even see it as 101.3 times 10 to the 3rd, even though it's not a good scientific notation. These are the same-ish enough. I mean, they're all the same. It's like what really exists in the world. All right. So this is the stumper. This is the sample. Which one of these has the largest pressure on the bottom? No, yeah, it is secret option number 4, that they're all the same. So a lot of people tend to pick 2 because they see, hey, look, all that pressure might be focused down on it, but honestly, they all have the same pressure because you got to also think, these sidewalls can hold things up, but it's asking what's the pressure at the bottom.